Hi, welcome to 5.0, Review of Transformations of Exponential and Logarithmic Functions. We're going to be looking at a lesson previous to 5.1, a lesson that I have decided to put in just to refresh our memories of exponential and logarithmic functions. So our goal for today is to review the properties of exponential and logarithmic functions so that we will feel more comfortable working with said functions as we explore more advanced concepts of calculus using these two types of functions. Okay, so let's start looking at transformations just to review a few things. First off, vertical stretches and compressions. If we have a coefficient in front of the base of an exponential function, then that will multiply with all the y values of exponential functions. So we see that the base function y equals 2 to the x is this lighter function here, and this next function is y equals 2 times 2 to the x. So the y-intercept of the base function then becomes 2. This value of x equals 1 and y equals 2 becomes x equals 1 and y equals 4. And x equals 2, y equals 4 on the base function becomes x equals 2 and y equals 8 as we multiply all the y values by 2. And then on the left side, the negative side of the y-axis, the same kind of thing happens when y equals a half. On the original, y equals 1 on the transform function. And when y equals a quarter on the original, y equals a half on the transform function when x equals -2. Okay, etc. and that continues. When you have a function y equals 4 times 2 to the x, same thing applies. All the y values now get multiplied by 4. So the y-intercept of 1 is at 4. X equals 1, y equals 2 becomes then x equals 1, y equals 8. And then the rest of the points are off the scale way up here. When we have x equals -1, y equals a half, on this transform function we've got then x equals -1, y equals 2. Okay, and the rest of that continues. And then when we have the original function multiplied by 7, same kind of thing goes, all the y values get multiplied by 7. Okay, as we could continue with that process. Moving to vertical shifts or vertical translations, as they're called, we've got the c value being added to the base function. And so here's the base function here, y equals 2 to the x, this lighter function here. When we're adding 3 to that, this y-intercept of 1 becomes 4. As we proceed along with the original function over towards -infinity, we see that it approaches a horizontal asymptote of y equals 0. For the transform function, where the vertical translation is up 3 units, that horizontal asymptote as x approaches -infinity is y equals 3. When the vertical translation is down 4 units, we see that the y-intercept, instead of being 1 for the original, is now at -3, and the horizontal asymptote as x approaches -infinity is actually -4. Okay, we'll just move right along here to the horizontal translations. And that's indicated by a plus or minus of some sort of constant in the exponent of the exponential function. And so here's the original function again, y equals 2 to the x. When we're adding 3 into the exponent, we see that the function gets translated to the left 3 units. So this value of 0, 1 becomes negative 3, 1. And all of the points follow suit. This value of negative 1, 2 becomes negative 2, 2. This point of 3, 8 gets translated over to 0, 8. So all the points just get shifted over either to the left or the right accordingly. So for the first function, they're all translated over to the left. The second function, when y equals 2 to the x minus 4, all the points get translated to the right 4 units. So the y-intercept of 0, 1 becomes 4, 1. This point of 1, 2 becomes 5, 2, etc. And this point of 3, 8 is 7, 8. Horizontal stretching and compressing is about the same, where we deal with the opposite operation that one might think. So when we're multiplying by k in the exponent, we're actually dividing all the x coordinates by that value of k. So again, here is the original function, y equals 2 to the x. When we have here y equals 2 to the 2 times x, around the y-intercept, of course, nothing changes because the x value is 0. When x equals 1 here, we see that multiplied by the exponent multiplied by 2 divides the x value by 2, so that instead of being the point 1, 2, it now becomes the point 1/2 and 2. This point of 2, 4 becomes then the point 1, 4, because the x coordinate gets divided by 2. The y value does not get changed at all. And we could continue on, but we've run out of room at the top here. This function of y equals 2 to the 3x, same kind of idea. The point of 1, 2 becomes 1/3, 2. This point of 2, 4 becomes 2/3 and 4, because we're dividing all the x coordinates by 3. So it just gets shifted over, or sorry, compressed 3 times. And then when we're dividing by a quarter, when we have 2 to the 0.25x, this point of 1, 2, we divide the x coordinates by a quarter, and when you divide by a fraction, you flip and multiply. So we're multiplying the x coordinates by 4, so instead of being 1, 2, it then becomes 4, 2. This point of 2, 4 would then become the point 8, 4. Okay, etc. What I would like you to do now is fill out the little transformation boxes that are down below the diagram here, right there. Can you please go through all the transformations? The graphs and the equations are given here, so that would make things a little bit easier for you, hopefully. So go through all the transformations from left to right through each of these equations. We've got equation G, equation H, equation R, and Q. So please go through all of those and list all the equations, the transformations, as you see them in order from left to right in each of those boxes, please. So pause the video now and go through those, and we'll come back and check your answers.